Hello everybody and welcome back to MA 206 online at Frederick Community College, summer 2017. So in this video I will mention everything you need to know about final exam, how to prepare for it, and all the little things that you should know before you go in and take it. Okay, first things are technicalities. When is the final? As I've mentioned it many times in my announcements and emails, August 7th through August 14th. Those are your dates, Monday through Monday. Including those dates, you guys can go into the FCC Testing Center and take your test at any time or on any day that's convenient for you. Okay, those are absolutely the only dates that you can do so. I will be picking up your test on Monday night or Tuesday morning, and I will be grading them and posting your grades on Tuesday, the 15th. Okay, so if you're wondering when you're gonna see your grades will be posted on Connect Math first on August 15th, and then that same day or maybe the following day I will post them on PeopleSoft. That's where your official grades will go in. Okay, all right, let's go ahead and talk about review videos. So you have here chapter 7 through 11 review videos. You don't have to watch them, but I strongly recommend watching these. Okay, they're not 5-minute videos, they're a little longer, but take the time to review them. I've got a lot of feedback from my face-to-face and online students saying these videos are very useful. Okay, I promise you I won't be wasting your time if you watch these videos. All right, let's see. What do you need to have? TI-83 or 84 calculator. Most of you bring your own. That's fine. If you want to ask for one, you can. And if, let's say you've been practicing your stuff with 84, make sure you ask for the 84 calculator. One formula sheet that is prepared by you. Okay, so let's make that official. What do we need to have? Okay. Calculator, formula sheet that's done by you. I know most of you are already aware of this, but there are still students who were confused about it. Make sure that you are the one who is preparing this. Okay, I will not be providing anything on the final exam as far as the formula sheet. Okay, so that's going to be done by you, and that's just another way for you to study. Okay, so calculator, formula sheet, whatever you want, no problem solutions. Okay, no actual problems that you write down. All right, you can write formulas, tricks, calculator commands, stuff like that. Okay. All right, let's see. So let's go back to that website. Okay, review videos and how do we study for it? So what is the best way to study? This is the best way to study. Okay, review videos. Watch them, plus all activity 7 through 11. Okay, every one of them. So now if you go on your course page, there's solution tab right here, solutions to activities 7 through 12. I'm not sure why I posted 12. Okay, yeah, I know. Okay, so we only have 11. I combined some of the activities to one. All right, so activities 7 through 11, one for each chapter. Make sure you guys know how to do these problems. I promise you, if you just know how to do all the problems, you can't solve all of them. That's okay. Then take a look at it. But the idea is that you at least attempted to solve all of them. That's the best way to prepare for paper pencil test. There is no computer program. There is nothing like Connect Math or MyMathLab or anything that's that good as far as preparation for the actual writing down test. There's just nothing like it. Okay, so please go through them. Please do it. Okay, this is very important. All right, so that's what you need to do to prepare for the final. Now let's go ahead and talk about the actual final. Okay, so just like before, this will be chapters 7 through 11, and how many problems? Just like before, 9 to 12 problems at most. Okay, so you might be asking, what should I study? What should I focus on? Which chapters? The answer is chapter 7 through 11. I will test something from each chapter. Okay, so maybe more than one thing. Something from chapter 7, something from 8, 9, 10, and so forth. Okay, so you can't just say, oh, chapter 8, I don't really get it, so I'm gonna skip it. Well, it will be on the test. It's a guarantee. All right, now let's see. The test is prepared in the same order as we learn the material, so it's in the same order. I'm not here to trick you guys. I just want to see if you understood the basic ideas, the main concepts. Okay, so test is in the same order, meaning I don't mix up the problems. I start with problems chapter 7. I pick a couple there, chapter 8, 9, 10, 11, and so forth. Okay, so just keep that in mind because it can actually be kind of helpful. All right, let's see. So that's to keep in mind about what material needs to be covered. I'll go through the calculator commands in a little bit. Let's see, what's one of the advice from me? Show all work, everything. Okay, now let's say you have a problem and I give you something that looks like this. So let's say you have the problem here, right? So just some problem written down, text, you read it, and then it says do the hypothesis testing, and then I'm gonna give you this setup right here, something like this, p-value, conclusion, right? So this one will already be on the test. You need to fill in everything. Okay, there is a point or a number of points attached to each part, so you fill this in, fill this in, fill this in, fill this in. Okay, don't miss and don't leave anything blank, because that's a guarantee that you're going to lose points. Or another thing, okay, so it will look something like this: calculator command if you're using something. Or if you're using it by hand, that's fine. If you find it something by hand, then you just say over here, I found it by hand. But if you see that there is something typed and I leave space for it, that means you need to fill this in. Okay? So if this problem, let's say this problem is 10 points, right? Then each part will have some amount of points assigned to it. Okay, conclusion. Remember, everything needs to be in the context of the problem. Okay? What does that mean? It means that you actually need to take the scenario that's in that problem and make a conclusion about it. If it's about proportion of children who are overweight, that's what the conclusion should be about. Okay, if it's about the mean salary of middle school teachers, that's what the conclusion should be about. Okay, not something generic like, oh, we have enough evidence to reject the claim. Yes, that's not good enough. Okay, you need to write it so a person that's not in the class can read it and say, oh, I know you made a decision about this particular situation. Okay, so in the context of the problem, that's important. All right, okay, let's see what else I want to mention. Let's talk about each chapter in particular. So now I think we're at point 5. Let's go ahead and just talk about each chapter. So chapter 7, confidence intervals. Calculator commands that you need to know: z interval, t interval, 1 proportion, z interval. Okay, now what else? You will need to know these two formulas that are not built in any of the calculators. So the sample size needed when you want to construct a confidence interval with some particular requirements, right? So this one, and then also for proportion, that's b hat 1 minus b hat z of alpha over 2. These two formulas, they're not in calculator. They're not in your calculator. Not in your calculator. You actually have to know when to use it and how to use it. Okay? So also you need to know z of alpha over 2 for 90%, 95, and 99. I will not be providing those values. They're very easy values to remember. If you don't want to remember, that's fine. Write it down, or you can use inverse normal to recover it. But this will not be given. You need to know this. You need to know this right here. Okay, these values. So these commands, these formulas are not in your calculator. I want to emphasize it because there is a problem where you're required to use these formulas. So what else do we need to do? Once we compute this for these two formulas, we always round up, right? Whatever the answer you get, we always round up. Okay, so that's chapter 7. Let's see, chapter 8. Oops. Let's go, chapter 8. Chapter 8 was hypothesis testing. Okay, now what I want to mention here, when you guys set up the hypothesis here, make sure you pay attention to your notation. If your problem is about mean, you need to be using mu. So let's say you have mu is equal to 40, mu is not equal to 40, if that's what your problem is about. If your problem is about proportion, then you need to use p. So let's say 0.15, something like this, right? So let's say you have this situation. I actually pay attention to this. And yes, I will be taking points off if it doesn't match, okay? So you need to, first you need to read the problem and decide, is it about mean or is it about proportion? And that's the notation that you go with, okay? It should be consistent through the entire problem, okay? And I'm gonna write it again. Everything, your conclusion needs to be in the context of the problem. Okay? All right. So your conclusion needs to follow the scenario, and you basically make a decision about the situation. Okay? Nothing generic. No generic answers will be given full credit. I'll give you some credit. You just won't get 100%, even if the computations are right. All right, let's see. So that's chapter 8. What I want to mention here. These are the common mistakes that happen a lot. Let's say you get a p-value on your calculator, and it looks something like this. Right, so something like this. Okay, so what happened before? People say, oh, my p-value is 5.24, that's greater than alpha level, whichever that is, because that's usually small. We fail to reject. H no. Okay, common mistake. This should not happen. Why? Because p-value can never be greater than 1. How can you have a p-value that's 5.24? This value right here is actually what? It's close to 0. That's close to 0. Okay? It's approximately 0. Because it's 10 decimal places to the left. So we have 90 in front of this 5 right here. Okay? And that changes the conclusion as well. So that changes the fact that you no longer reject, or you no longer fail to reject. In fact, you have very strong evidence to reject the null hypothesis. So please don't be that student that decides all of a sudden that you have probability that can be greater than 1. Okay? Pay attention. As soon as you get a p-value that's this big, you say, wait a minute, this can't be right. Let's go back and see what happens. Oh yeah, okay, this part right here, that tells me this is scientific notation. Okay, so what else can happen? What if you get a p-value that looks something like this? So let's say you got a p-value and it's 0.99924. Now that one is still less than 1, right? Now whenever you get a p-value that's this close to 1, this is really close to 1, something went wrong every time. Okay, go back to your calculator and see what happened. You probably set up your alternative hypothesis incorrectly, because when you have a p-value this close to 1, it's kind of like the same thing like if you were trying to put somebody in jail for, let's say, a crime that happened in Baltimore while this person was 100% in California. You know, it's like, okay, wait a minute, the evidence points in complete opposite direction. That's what the meaning of this. Okay, so p-value is close to 1/2, that's okay, that can happen. But whenever you get something close to 1, just remember, say, wait a minute, this is way too close. This is just basically saying this 100% did not happen. Okay, that's what you should really think about. Okay, so go back and double check your alternative hypothesis, or maybe you plugged in something wrong in other places. But that's my hint for chapter 8. Okay, your p-value should never be this big, ever. All right, chapter 7, 8 done. Chapter 9, let's see, chapter 9. What did we do here? Okay, this is inferences on 2 samples, right? So what your null hypothesis would look like, something like this, right? Or mu1 not equal to mu2. That is for independent samples. Then if you have paired data, that's about a difference, mu d. Okay, there should be some number. A lot of times it's 0, but it doesn't have to be 0. Okay, this could be some different number. Make sure you read the problem correctly. Okay, and there are a couple of examples in activity 9 where the difference is not set to 0, it's set to something else. Okay, and then what else is there? When we have hypothesis about 2 proportions, right? So you got to remember this part. Okay, these are your 3 scenarios. Obviously I'm not gonna test all 3 of them, because then you're gonna run out of time, but 1 or 2 problems, yes, this should be, you should feel comfortable with dealing these type of problems, all 3 types. Okay, so read the problem carefully, say, okay, I have 2 samples, what am I dealing with? Proportions? All right, then you go and deal with proportions. Is it 2 means? Okay, 2 means. Are they independent samples or is it paired data? And so forth. And there's a whole review videos about chapter 9. Same thing here for p-value. Okay, p-value, same as before in chapter 8, cannot be close to 1. Also cannot be greater than 1. Okay, and your conclusion in the context of the problem. Okay, chapter 10. Chapter 10, what is this? This one was inferences with qualitative data, right? So we have chi-square goodness of fit. Okay, and then we have chi-square test for independence. Okay, independence. These 2 problems, these 2 types, you should know how to deal with both of them. All right, so somebody asked me this question, if I'm gonna give you the table with chi-square values. The answer is no, but I will give you the values on the actual test. So the chi-square from the critical value will be provided, okay? So I'll just tell you right on the test what that value is, so you don't have to worry about looking it up and think about alpha level and degrees of freedom. It will just given to you. If you want to use the p-value method, that's fine too. So just write, okay, p-value method where you don't need this value is fine, and that's for students who use TI-84 calculator is okay too. Whichever one you would prefer is fine. Okay, so goodness of fit test for independence. The most difficult part that I found for student is to finding frequencies, expected frequencies, computing the expected frequencies. Okay, so make sure you know how to do it. Most of the time for goodness of fit, it will just say all numbers are the same. It's not always the case, but many problems that we've been dealing with so far, we're assuming that the distribution is completely uniform, meaning probability of each category is the same across the board. So you add them up, you add up your observed values, divide by the number of categories, right? Now, as far as the test for independence, just use the matrix. That's the easiest thing to do. So for this one right here, you don't have to use it by hand. Just compute with the matrix. Compute with the matrix method. If you want to know how to do it and you still don't, there's a video on Blackboard that I linked that tells you how to do it. Okay, so this test right here, this command is included in both TI-83 and 84. For goodness of fit, for TI-83 students, if you guys watch my video, you will see how to deal with that. Okay, so there's still a little longer way, but it's doable. So that's your qualitative data test. Again, your conclusions should be in the context of the problem. Another thing that is very common, so when it's test for independence. Okay, let's go with that. Okay, so whatever your variables are here, whatever the two qualities are, so let's say gender and music preferences, this line right here at the top line, the null hypothesis, will always say these are independent or no relationship or no association. Okay, and then this one will say not independent, not the other way around. Independent. Okay, so that means there is association. Okay, or you want to write dependent, that's fine too, but please don't mix them up because you will make a wrong conclusion. Okay, null hypothesis independent, alternative hypothesis not independent, there's some sort of relationship going on. Okay, so that's that. Let's see, chapter 11, that's the last one. Chapter 11. Okay, this chapter students have usually no problem whatsoever. Just make sure when you plug in your numbers, this is regression, right? So regression and linear regression and correlation. Make sure that you plug in numbers right. That's about it. Okay, so this one students do typically really well. The only thing that you need to know here is what linear regression t-test, how to conduct this test right here. You do not need to know how to do linear regression t-interval. This one you can go ahead and not worry about. Okay, don't worry about this one. I will not ask you to construct t-interval, but t-test, yes. So there are 4 problems on activity 11, so check out those to give you an idea of what your solutions should look like. Activity 11. Okay, so for linear regression t-test, the main idea here is to figure it out if the linear model is appropriate in this particular situation. Is it a good model to use for predicting one variable from another? Okay, and if we reject the null, that means yes. So let's see, let's say you set up something like this. I'm gonna just give you a quick example, right? So the null hypothesis will always say, no, there is no linear association. This means right here, okay, the slope is 0. That means the linear model is not good. Okay, and then the alternative hypothesis will either say not 0 or greater than 0, less than 0, depending on the situation. Okay, so let's say you got a p-value that looks something like this. All right, and your alpha level is typically 0.05, right? So that's less than 0.05. That means if this is this small, that means the linear model is good. So whatever you've computed, mx plus b, right? That's your line, really. Mx plus b is a good model. Good linear model for predicting whatever the variables are. Okay, now let's say you have a p-value that's got 0.345 that's greater than 0.05. We fail to reject the null hypothesis, right? So we cannot reject this one. We cannot reject this one. That means what? Y hat is no good, is not appropriate. Okay, and then you would just use the situation to write your conclusion in the context of the problem. So let's say you had energy and income, right? That's one of your problems. You would say, okay, no, we should not be using income to predict energy consumption, or whichever the answer is, right? So that's what you would write as your last statement, as your last conclusion. Okay. All right, I think that might be it. Let's just see real quick. Okay. Calculator, formula sheet, reviews. I cannot emphasize this anymore. Okay, activity 7 through 11. Okay, let's see, show all work. Yes, definitely do that. You will get a higher chance of getting some additional points even if your problem is not exactly right. Okay, then fill in all of the blanks, and then each chapter is mentioned. Well, there's only one thing that I can tell you guys is good luck. And this is not me being sarcastic, this is actually me being really sincere. Good luck, everybody. Take your time, go in, be relaxed. I'm not here to trick you. I just need to see that you guys got the main concepts, and if you did, that's awesome. You just guys finished one of the most challenging classes online over 8 weeks. You should be really, really proud of yourself.